In this integral, we can rewrite the square root as a 1/2 exponent, but there doesn't appear to be any way to multiply this out or simplify the integrand in any way that's going to allow me to anti-differentiate without substitution. So I will try a substitution. I'll let u be the inside on this again, x squared plus 4, and see how that works out. Du is, as always, is a calculation. You differentiate u, in this case derivative x squared plus 4 is 2x, and you multiply by dx. Now our goal is to rewrite the original integral in terms of the new variable u. A portion of this is always easy. Wherever you selected your u from, you start there. This is a u to the 1/2 exponent. That takes care of all of that. And what's left over is a 2x dx. dx is always found in the line that comes from du, and so we try and see how much of that we can cover. And what we see here is everything can be covered exactly with the du. This fit beautifully, actually. No additional algebra to do. So this one I would refer to as a type 1 integral. Very little to do in terms of the substitution. Simply select the u and the du, calculate the du, and the integral simplifies itself. We can now then anti-differentiate this by increasing the exponent by 1 and multiply by 1 over the new exponent and adding on our constant of integration. If we then return to x's, x squared plus 4 is what u is equal to, so we are done with the anti-differentiation right there. I always like to check these. The check will involve a chain rule. We differentiate our answer and expect to get our question back, the integrand. And according to the chain rule, let's see, I'll pull my 2/3 out of the way. Chaining on this portion, I'll bring the exponent down, leave what's inside alone, reduce the exponent by 1. 1 less than 3/2 is 1/2, and then multiply by the